This is going to be a quick video on formula mass. So the formula mass of a substance is the sum of the average atomic masses of all the atoms in the substance's formula. Now we know that covalent substances exist as discrete molecules, and so for covalent compounds, the formula mass can also be called the molecular mass. A more old-fashioned term is molecular weight, but we prefer the term molecular mass. So if we were asked to calculate the formula mass or the molecular mass of glucose, the formula for glucose is C6H12O6, and so we have 6 carbons, so I would do 6 times the average atomic mass of carbon, which is 12.01. I have 12 hydrogens and 6 oxygens. Now students often ask, how many decimal places should they use in the average atomic masses when they're calculating the formula mass? And the answer really depends on, when we use the formula mass in a calculation, how many significant figures do the numbers that we're dealing with have? Because you always want to use more significant figures in your formula mass than you have in the numbers that you're using in the calculations, because we don't want to limit the precision of our answer based on the precision of our formula mass, because we can make that very precise. I think the shorter answer is, in most of the calculations we'll do in this course and in most of your other chemistry classes, if you use 2 decimal places in the formula mass, that's generally going to be enough precision for the calculations that we're doing. But you want to be careful. If the numbers that you're using in your calculations are more precise, you need to use more decimal places in your formula mass. So when we add all of that together, we get a formula mass of 180.18, and then the units would be atomic mass units, or AMUs. Alright, now when we're dealing with ionic compounds, we know that these do not exist as discrete molecules. And so the formula mass for an ionic compound should not be called the molecular mass. However, you calculate the formula mass for ionic compounds just as you would for covalent compounds. Just as a quick example, if we wanted to know the formula mass of aluminum nitrate, I'd first need to know the formula of aluminum nitrate. And so aluminum has a +3 charge, nitrate has a -1 charge, so the correct formula would be AlNO3 3. And when we calculate the formula mass now, I have 1 aluminum, so I would use 26.98. I have 3 times 1 nitrogens, so I have 3 nitrogens. And then I have 3 times 3, 9 oxygens, so I'll do 9 times 16.00. And when I add all those up, I get, 213.01 AMUs.